In this video, you're going to explore the differences between synchronous and asynchronous execution. We're going to start things off by defining those two terms, then we're going to explore the differences between the two in two ways. The first is via a code example, and the second is via a quick slide. It's just one slide with some animations that's going to make it easy to visualize how these two different approaches get the job done. Let's go ahead and start by moving into app.js. Now, the example we have right here is an example of asynchronous execution. When we execute something synchronously, we start some sort of task, like fetching a puzzle, and then we have to wait for it to finish before we move on to the next thing. When we execute something asynchronously, we can start some task, then we can actually get other work done before the task completes. So for example, down below, console.log, do something else. When we run this program, we're going to see do something else print before we either get our puzzle or the error message. That's because we're using asynchronous execution. Yes, we start the process of getting the puzzle before this log, but it doesn't complete until after this log runs. If I save the program, over here, we get the expected results. We get do something else showing up right away. Then you could see about a fraction of a second later, we got this message printing. So this is asynchronous execution. We can actually create a synchronous version of getPuzzle, and we're going to do that just to illustrate the differences between the two. So down below, what we're going to be able to do is the following. Const puzzle equals getPuzzle, and we need to name it something unique, so I'll use getPuzzleSync, for example. We're going to call it, and then we will be able to console.log puzzle. So in the last video, I mentioned that this was not possible. There actually is a way to get it done, but it is not a way we want to use when we're working with JavaScript. The only reason we're going to be messing around with this is to prove a point and explore the differences between the two techniques. So let's go ahead and create getPuzzleSync so this code actually works. To do this, we're going to start by just duplicating getPuzzle. The code is going to be very similar. I'm going to take the function, I'm going to paste it down below and then just change the name over to getPuzzleSync. GetPuzzleSync isn't going to take a callback function, so we can actually delete this. What we're going to do is make this request synchronous. So with an asynchronous request, we can do other things while we're waiting for that data to come back from the server. And this is good because, as I mentioned in the last video, this could take a decent amount of time, maybe 100 milliseconds. That might not seem like a lot, but if your browser stopped for 1/10 of a second every once in a while, you would definitely notice. So down below, what are we going to do? We're actually going to pass a third argument to request.option. The third argument lets you define if you want this request to be synchronous or asynchronous. Now, by default, it's true. This means we have an asynchronous request where we can move on and do other things before the HTTP request completes. If we change this to false, though, we're actually forcing our code to wait until the server responds with the puzzle. Now, this means we can change up how this function looks. What we're going to do is take everything inside of our readyStateChange callback function, and we're going to cut it out. We're actually going to be able to remove that function completely. Then down below, after we call request.send, we're going to paste that code in. Now this code currently relies on e.target, which was the request itself. We no longer need to use e.target because we have access to request right here. So all I'm going to do is replace all instances of e.target with request. So here it is request.readystate. Over here it is request.status. Down below it is request.responseText. And then finally we have one more instance right here, request.readystate. Now with this approach, we can actually use the return statement. So right here, I'm going to return data.puzzle, and this is indeed going to work as expected. We can remove the callback from here, and down below, we could also add something in for when things don't go correctly. I could, for example, throw an error. Throw, new error. We could print a little message, things did not go well. Very useful, very descriptive. So in this example, the code down below is never going to run until after the server responds with the data. That's why we don't have to rely on an event listener. Let's go ahead and save the program in requests.js. And before we save app.js, we're just going to do something else, cut it out and move it down below. And then we will comment out the example up above. So previously, we used an asynchronous version of getPuzzle with a log after. Down below, we're going to use a synchronous version of getPuzzle with a log after. Let's save the program and see what we get. This time around, aside from getting a warning, we can see we're getting the puzzle first, wireless remote control. Then after that, we're getting do something else. So with the asynchronous approach, we're able to start a process and continue running other code. Eventually, the thing that we run completes, we get our data back, and we run the callback function. This allows us to keep running other code while we're waiting 100 milliseconds or whatever the time might be. Down below, for the synchronous execution, we actually have to wait all 100 milliseconds, even if something else that runs later on isn't related to this data at all. So in this example, we see that the puzzle prints first, then down below, we're able to run our other task. So we can see why this is not what we want. I don't want task 2 to need to wait on task 1 if task 2 doesn't need any information from task 1. Up above, we were able to get both done at the same time. Down below, we had to wait for one to finish, which took some time. Now let's dive into the actual warning. Over here, synchronous XML HTTP request on the main thread is deprecated because of its detrimental effects to the end user's experience. So this is saying that what we've done by creating a synchronous request is actually going to be really bad for the end user, and it's true. Not only are we preventing other unrelated JavaScript code from running and getting some work done in the meantime, we're also locking up the user interface. Now this is a bit hard to tell because we have nothing interactive. To simulate this, let's just go ahead and add in a checkbox. A dummy checkbox we'll delete in a few minutes. Input type equals checkbox. Now this shows up to the screen, and before we can really get our mouse over there, everything's finished. So it's a bit hard to actually prove that things are getting locked up. We can go ahead and slow down our request though. Over here, we're going to switch up the URL we use in getPuzzleSync. I've created an alternative URL that is the exact same thing. It still returns a puzzle and accepts word count. It just waits 5 seconds before doing anything. That is /slow-puzzle. If we save the file in its current state, that's going to give us a little bit of time to get our mouse over here and actually mess around with things. So down below, we can see that nothing's printing in the console, and I'm clicking the checkbox, and it's not actually accepting my changes. Now, after things print, after the synchronous request completes, I am able to check that checkbox. But for the entire time the request was happening, the entire browser was locked up. This is something we want to avoid. Instead, we want to stick to asynchronous code, which allows us to do other things while we're waiting for our long-running tasks, like HTTP requests, to complete. So that's the actual code example that explores the differences between the two. Now I want to move into the visualization. Let's go ahead and remove getPuzzleSync. Inside of app.js, I'm going to go ahead and remove its usage and the console.log down below. And I will uncomment getPuzzle called with the callback function. Let's save that file too. And then lastly, I am going to remove the checkbox. All right, that is it for the code side of this video. Let's go ahead and jump into the visualization. On the left-hand side, we have a synchronous example. On the right-hand side, we have an asynchronous example. And down below, we're going to explore the timeline for how both actually execute. Now, in the end of the day, both scripts are solving the same problem. I'm getting two unique puzzles and printing them, and I'm also printing a message at the end of the program that just says end of program. It's not what they do that's different, it's how they do it. So for the left-hand example, I have a function called getPuzzleSync, much like we had before. And for the right-hand example, I have a function called getPuzzleAsync. I've renamed it from getPuzzle to getPuzzleAsync just to clarify the differences in our two examples. Let's start with the synchronous example. Over here, we're going to run through all 5 lines. And the first thing we do right here is we get the first puzzle. Now I'm representing this process with a rather long rectangle since it takes a little bit of time. We have to make the request, send it off to the server needs to do its work and respond, and we have to wait for it to transfer between our machine and the server via our internet. Now that is the first thing we do, we get that puzzle. The next thing we do is we print the puzzle. Printing the puzzle is a super speedy operation, so I've represented that with a much shorter rectangle. Now that's lines 3 and 4. After that, we do the same thing for our second puzzle. I get the second puzzle, which takes just as much time as getting the first, and then after we get the second puzzle, I go ahead and print the second puzzle. The last thing I do is print the end of the program, once again being represented by a very small rectangle since that process is super quick. And this is a pretty straightforward order of events. We can see that as the lines execute, we perform that operation. We get the puzzle, we print it, get the puzzle, print it, and then print our message exactly like we see here. So that is the synchronous example. Now I want to explore the asynchronous example to see how that executes. This is going to shed some light on other advantages we haven't talked about so far. The first step for our asynchronous example is actually represented with a short rectangle. Here, we start fetching the first puzzle. Notice I just said start, I didn't say finish. So yes, we still need to set up our XML HTTP request, and yes, we still have to send it out. The difference though is that we don't have to wait for it to come back in order to do something else. So after we start fetching the first puzzle, we move on to the next thing, which is to start fetching the second puzzle. Just like we did for the first, we have to set up this request and send it out into the world, but we do not have to wait for the server to respond before we can move on. So at this point, you'll notice that we have two pending HTTP requests both out there in the world. We're waiting for two responses. Now, what's the next thing that happens? Well, the next thing that happens is that we print the end of program. Now, at this point, what do? We just sit around and wait. We wait the same amount of time we would have waited in the synchronous example for the HTTP request to complete. So down below, step 4, I represented that by starting with a rectangle with a dashed border. This represents the amount of time we're waiting, and then after the waiting is complete, what do? We print the first puzzle. Now we move on to the other one, which is to print the second puzzle. This happens just after the first puzzle prints. Now there's a big difference between the two. In the left-hand side, you'll notice that at no point is there any overlap. So at no point can we draw a vertical line and run into two rectangles. This means that we're only ever doing one thing at a time. Over here, we have quite a bit of overlap. We have a ton of overlap when waiting for the two requests, and we are even able to start requests and print the end of program message while we're waiting for some of those requests to complete. So for the sake of easy numbers, let's imagine it takes a full second for an HTTP request to finish, for us to get the puzzle. It's going to take a full second no matter which way we're operating in. So over here, we wait a full second. Then we wait another second, and the whole program takes about 2 seconds to complete. The amount of time to print the messages is negligible, so I'm going to exclude that from my count, maybe a millisecond. Now on the right-hand side, we still have to wait a full second for the HTTP requests. Just because we're using an asynchronous form of execution doesn't mean the request time itself is any shorter. The difference, though, is that we have a whole bunch of overlap. We can perform other things at the same time, and I can actually wait for both of those 1 second requests to finish at the same time. So instead of waiting in series, one after the other, I'm waiting in parallel. The end result is that our asynchronous example finishes in about half the time as our synchronous example. Not only is it a lot faster, it also does not block the user from interacting with the user interface, and it doesn't prevent other unrelated code from running. Now here we're using the terms synchronous and asynchronous. You might also see people refer to this as blocking and non-blocking. This would be blocking because it blocks other code from running before something finishes. This would be non-blocking because you can run other code while we're waiting. Those terms generally refer to the same thing, though I'm going to be using synchronous and asynchronous to describe the two different approaches. So that's where we're going to stop for this one. At this point, we should have a decent understanding of why we are preferring asynchronous execution, working with our callbacks. In the next video, you're actually going to create a callback of your very own for fetching the country information. If you have any questions about what we learned here with callback functions and asynchronous execution, please do not hesitate to ask a question in the Q&A. One of the reasons you paid for a course was not just for a set of videos, you paid to get help when you need it, and we are there to provide that help. So if you have a question about what's going on here and you're unsure exactly why things are working the way they're working, just ask a question and we'll get back to you right away. All right, that's it for this one. Let's jump into the next one.